So now we will move on to the normal distribution. And we'll first start talking about continuous random variables. And so in a continuous random variable, essentially, you can't have probability of an exact value. It's impossible. Instead, you have a range. And so this means that when you graph it, I think you saw with binomial, it's like this. It peaks at the this is like binomial. And these things are actual probabilities. And it's the same for geometric. But for a normal distribution and any continuous random variable in this distribution, these are not probabilities. It's called a probability density function, so it just tells you where a lot of values are, and area under the curve is probability. Now the continuous random variable that you study in AS is the normal distribution, are normally distributed continuous random variables. And they are key for being symmetrical, like this, and they are centered at the mean, and then they move out in units of 1 standard deviation. And as you increase mean, you shift whole graph to the right. And then if you do down, shift to left. You decrease the standard deviation, curve becomes taller and thinner, so less spread out. And so pretty much, and by a proportional amount. And then if in the opposite, if you increase standard deviation, then you make it, the peak is lower, and it's more spread out. And as you can see with the normal distribution, it's symmetrical, so the probability decreases equally as you go the same distance away from the mean. So this is you're able to compare some distributions. So here you can say mean is greater and the standard deviation is greater. Then here you could say mean is lower and the standard deviation is also lower. So now we'll hop onto Desmos and take a look at the normal distribution and the effect of changing the mean and the standard deviation visually. So we'll start with maybe a mean of 1 and a standard deviation of 2. Stretch out these axes so you can see the effect a bit better. So you can see you've got the peak at 1. And then I'm going to compare it to another normal curve, say with a mean of, mean of 0 and a standard deviation of 1. Notice how the second curve is with double the standard deviation is half as tall and 2 times as wide. And because it's got a mean of 1 more, it's 1 to the right. We call a normal distribution with mean 0 and standard deviation 1 standard normal. And so if we do the notation, we do x is distributed in a normal distribution and the parameters are the mean and not the standard deviation, the variance. Now that's the annoying thing about Desmos. You have to put in the standard deviation even though the actual parameter for a normal distribution is the variance. From the next video, we'll move into calculations involving the normal distribution.